let's go over those equations really quick, because, oh, welcome, Quentin. So that way, since you were asking about this one, alright, what is the equation for Boyle's Law? We'll start with you, Chris, let's work our way around.
P1 times V1 equals P2 times V2.
That is correct. Anyone have any questions about how to work this? Okay, go.
Wait, times?
P1 times V1 equals P2 times V2. Okay.
15.
Alright.
Thank you.
Charles' Law. I know it's not there.
Charles' Law is V1 over P1 equals V2 over P2.
Get it up. Alright. Here's 5.
I'm 12.
12. Alright, Ethan, what is the combined gas law?
P1 times V1 over T1 equals P1
You said P1 again?
P2
There you go.
times V2 over T2.
Alright, anyone have any questions about that one, or how to solve any of these?
Can we work out the last one?
The last one? Alright, so really quick,
I think we did this one yesterday in study hall, didn't we?
we did the ideal gas law in study hall. Alright, so let's say for this one, Chris, that the pressure is 1 atm, the temperature is 250 degrees Kelvin. Let's see, we'll say the first volume is unknown. We'll say the second pressure went to 2 atm, I'm keeping it really simple. The second volume, we'll say, is 75 liters, and then the second temperature is 280 Kelvin. Alright, how would you solve for this?
What is volume again?
Liters.
Liter, that's one. I know, like, what did you get for volume?
Okay, so we're missing this
Oh,
volume 1.
Okay, so you do 1 divided by 275.
Okay, so 1 divided by 275, and then what do you do? What I would probably do first, honestly, is I would just put, I would go ahead and cancel these out. So we can go ahead and move it. So you can get V1 by itself. How do you cancel these out? What do you do to get rid of this in algebra?
Multiply by T1.
Multiply by what?
T1. On the
Yeah,
other side.
so move it over here. So if it's 275 down here, you would put 275 up here. Alright, and then if it's 1 times it, where does this go? Where does the 1 go?
Dividing.
Yeah, or 1 would technically cancel out, but I mean it won't hurt anything to move it either. Alright,
So you would multiply, if it say it wasn't when they said it was 5, you would multiply 5 by 280 if it was there, for example.
down here in the bottom, yes, you would. Okay. So plug it in. Let me type it in because I did not solve
Wait,
this
that's
ahead.
trying to find what?
If you're trying to find V1.
Oh.
75 divided by 280 divided by 1, that basically cancels out. Alright.
147.
Yep, 147.3. Oh, we're not going to worry about sig figs, but let's say, for example, that I asked for 3 sig figs. What would the answer be?
147.
Yeah. Alright, and then if it's in volume and if it's liters over here, what would it be over here? Liters again. Alright, anyone have any questions though about how to solve this? So again, you just plug in all of your parts and then just solve it.
That is combined gas law.
That is combined gas law. Alright, Jimmy, what is the ideal gas law?
That is PV, or like P times V equals nRT.
Yep, and I will give you R if I ask for it because I know it's been a long time to memorize that. Alright, anyone have any questions about how to solve that one because we worked it in class? Alright, what is the equation for specific heat? Nope.
I have it.
No, it is specific heat. I drew it like to say which one was.
Equals Q over N by Q.
Alright, anyone have any questions about how to solve?
It's wrong.
That is,
That's wrong.
what's the
It's
equation?
delta C, isn't it?
No, it's not. It's M delta Z.
It's delta C. C represents specific heat. Alright, anyone have any questions about how to solve this?
And that's ideal. That's all.
Oh, this
And
one
that's-
is ideal gas law. This is specific heat. Alright, anyone have any questions about it?
Are we gonna need to know like the conversions from Fahrenheit to Celsius and Celsius?
For this one, I just give it to you straight because it's been a long time. This is a semester review. I'm like, okay, I think I asked you to do it on the quarter exam around like October. So because it's like, I assume you got it by this point. So you don't have to do that particular one.
No, I definitely not.
Mm-hmm.
And it's not like, definitely not like I got like a. No,
Alright, well, I can go on. Alright, so the last equation we talked about was energy transfer with the first law of thermodynamics. So what is that one? See,
Q.
Jamie just went, so it's Ethan's turn.
Ethan just
I just want
Okay.
all side of
Q plus T.
Yep. Wait, not
Q
T.
plus
Q plus. It's not T.
It's not T.
work.
Q plus joules.
Okay, joules is the SI unit for work.
W.
W. Alright, anyone have any questions about how to solve something like this?
No.
Alright, I've believe that's all the equations I wrote on the
Do I
board.
get it, wait,
Oh,
Yeah.
did you
oh,
take
what's
it?
that last one?
Oh, yeah, we didn't get to figure.
I'll let it in a second. Which which
What's it called?
This one? It's the equation for solving the first law of thermodynamics with the idea of energy changes.
We didn't,
I know, I forgot, I'm sorry. Okay, I think Ethan, you didn't pick, I don't think Jamie picked it either.
36.
Jamie picked 15, or not 15, she picked, 12.
Did you pick Jamie?
I think that's for the last round. I'll pick 20.
And I did one too.
Okay.
8.
Chevy started out.
Alright. Anyone have any questions about the map? I believe that's all the map I wrote on the board yesterday. This is all the map that you were responsible for.
After we finish, one of us can go to darts, cause that's like why I wanted to do this, cause I thought it was gonna take long.
No, other people may want to too. Alright, so, yes.
Do we go over with that Gibbs free energy?
You don't need to know that for this test.
And what about the heat fusion, heat vaporization? Do you have to use
Like, you
equation
need to
with
know,
that?
okay, like, which, like, heat of fusion is, if you're going from what state to what state?
Is it, let me not cheat, it's going from heat of fusion,
Heat of fusion.
from liquid to solid,
Liquid to solid or solid to liquid, and then heat of vaporization is from,
liquid to gas.
yep, or gas to liquid, just depends on what direction you're going. Alright, so you just need to know like the terminology, you don't know the equation for it. Alright, the other thing you need to know is balancing, like, but that's not really an equation, you might have questions about balancing.
This entire exam is just a ton of memorization.
Yes, a huge chunk of this exam is just memorization for it.
And then we're
What's
gonna
that online?
Yeah,
We're
what?
gonna need to know would they be scientists or professors?
Oh, we went over scientists, I guess is the best word for them, cause
Alright.
some of it was kind of abstract, but I guess scientists. Anyone have any questions about the math? 'Cause I think that's all the math stuff you need to know, besides like balancing.
Have you ever heard the story about the guy?
quick question?
Yeah, have you ever heard the story about the guy that, he was in college, and then he was late to class, and class had ended, and he saw on the board 2 problems that I guess he thought the professors had for homework.
Is this
And
really fast?
Yeah, he ended
Okay.
up solving them, and they were 2, notorious, problems that had never been solved.
Oh, good for them. Oh, I forgot molar mass. Anyone have any questions about molar or molecular mass?
Oh, that's what I was going to
I was
ask.
going to ask. I was like, I feel like I'm forgetting something.
I was trying to forget something, that's what I want. You add them on there,
Yeah,
Okay.
you'll have it. You have it
You have
stapled
it,
to
okay.
look the back of it.
you add it on
You
there.
just add them up together so it fits.
And one of them is grams and one of them is
Alright,
You.
so carbon is 14.01. Oxygen is 16.
16.00.
So it's 32.
And you add it,
Yep, so it'd be 46.
46.01.
Alright, so if this is molecular mass, what would the units be?
I believe,
U or AMU. If it's molar mass, what's the units?
grams mole.
Grams per mole. So
Is
that's
he
the
gonna
only difference.
Does he get a pick for that?
Well, he was asking about a question kind of like
Molar
as
mass?
you were. What?
Molar mass is
Molar
grams.
mass is grams per mole. Alright, anyone have any questions about, I believe that's all the math now. Don't let's forgetting something. Okay.
I think, I don't know about y'all, but I need to go over the
Scientists?
the different laws.
Yeah, okay, we can go over the different ones.
I think I'm good at it, but I'll
We
really
can go over because there is a bunch of the different theories and the models. So who is the person, we'll just go back, I think you just went and answered the question, pick the number. So,
I did?
I think so, we'll start with you.
I
Alright,
did the energy question.
okay, so, who came up with the quantum model?
Thompson.
Thompson?
10.
J.J. Thompson?
J.J. Thompson. Alright, who came up with the idea of orbits, with the idea of they're locked into these lines basically?
Born?
Which one?
Born?
Bohr or Born?
Born.
No.
4.
Bohr.
Can I get another question?
Nope.
28.
Is that 28? Alright. Who came up with the wave mechanical model? With the idea of the standing waves?
What does it start with?
S.
Schrödinger?
Yeah.
Who?
Schrodinger.
5.
So if I were to write Schrodinger as the actual answer, but I put in parentheses Stroganoff, would that be wrong?
As long as you make clear this is my real answer, I will take it. I'm not grading the silly answers, but don't waste too much time on it.
Well, I know I'm not gonna take the whole hour.
You probably won't, honestly, it should be that way.
How long is it?
Hour 50 minutes.
This test is 79 questions.
Yeah, but you said you were on 62 or something.
In US history, I'm over 100 now.
What?
Yeah.
You're gonna make this a 125 question, aren't you?
I'm shooting for more.
More than 125.
That's easy.
You better get more than an hour and a half for this.
No, that'll be fine, cause some of those are really obvious from the beginning of the year. Some of them are crazy obvious, so you should be fine. Alright, if believe it is Eastern. Alright, Ethan, what is the principle that says it is impossible to determine the momentum and velocity at the same time?
Let's start with
You.
uncertainty principle.
Yep, or the Heisenberg uncertainty principle, something you learned it last year, that's fine. Physical science. 2 years ago, whichever one it was.
23.
23. Alright,
Wait, do you know where it is?
I actually forgot because I picked a different one. What is the principle that states that no two electrons in an atom can have the same set for quantum numbers?
Start with an H.
Starts with P.
P is Pauli's
Poly.
Huh?
Poly.
Pauli uncertainty principle.
Okay, you're combining two different ones.
I know. Pauli and what is the other one?
Starts with an E.
Pauli. An E. Pauli. Oh, okay.
Alright, alright, we'll just go to Jamie next.
Poly exclusion.
Poly exclusion principle, saying they can't have the same force.
Number one.
Okay. Alright, what is the principle that says they will occupy the lowest orbital available and then fill in from that?
Let's start with
A.
off.
Are these gonna be on my website tonight? You think?
I will shoot for it, but it just depends on how much time I have to grade, but I will shoot to have them on by tonight.
Just don't be like Pastor Ron, who hasn't put
No,
these
no,
in.
don't,
Yeah,
don't
they're
critique,
still not
don't
very
critique,
well.
okay. Good spot for
20.
Good job. Oh, I said a good spot, okay.
How'd you get it to make the noise?
I choose a different screen, like a different starting point.
Can we go over, the like corners of the
Okay,
periodic?
yeah, we can do that
You
as
guys
well.
wanna do darts one?
I don't mind doing ours.
Or do we?
Jamie, do you wanna use more time? We only have about 20 minutes left.
Let's go darts.
Okay, we'll switch over to darts then. Keep in mind, though, that
turn
this
it
slows
around?
down. What?
Do we turn it around?
Do y'all wanna use this one or do y'all wanna use the other one?
I've never used that one.
So this is
I like the other one more.
Alright, we'll just use this one for right now, but if you'll hate it, you can flip over to the other one in about 5 minutes. Alright, so going really quick though, what is the principle or the rule or the idea since I'm on this page that says whenever you have a substance filling in a p, d, or f orbital, it'll just put one per orbital before it goes back and pairs up with it. What is that
Is it
called?
my turn?
I think it is your turn.
It starts with an O?
Starts with an H.
An H?
H.
It's the Hun's rule?
It is Hundrel. Alright.
You give me
What
a
is
lot.
that definition again?
It's a definite, hang on, Chris. Yep, okay.
Yeah, I don't wanna expose you.
Alright, what does it say whenever it's a P, D, or F subshell being filled, one electron will, will occupy each orbital before it goes back and pairs up? Okay,
We'll fill one electron before it goes.
yeah, because remember, like the P, there's 3 orbitals, so there's 1 in each orbital.
This
within
is
an electron.
Huns?
This is Huns.
And how's that different from the off?
Off-ball says it'll fill like energy level 1, and then energy level 2,
I'll
and
remember
energy level
this
3.
because then we filled it.
So energy level 1 and level 2, and then the other one, the Hun's rule is it will only fill one electron.
And like, this is all like in 2p, but it'll go 1 in each orbital spot before it'll go back and repair again. I'm sorry.
No, switch.
Not too hard. Alright,
It deserves it.
what do we call, let's see. Oh, Jamie, you were asking about the corners. So, what corner of the periodic table has the most, no, we'll go with least, has the least metallic character?
The least top character would be the top right.
Yep, it is top right. Come through.
Not here. Yes. Look at Mana, man. Throwing away a perfect 100.
What?
Look at Mana, man. Throwing away a perfect 100.
Alright, what? Yeah. Alright, Ethan, which corner has the most negative electron affinity?
Top right.
It is top right.
Why is there a hole here?
They used to put screws in it to hang stuff up there, our previous
Explain
teacher.
electron affinity.
So that was for electron affinity.
Electron affinity, remember it's to add an electron, the more negative it is, the more stable it is. Because remember, oh, Chris, this is a good question. If you have negative energy, are you exothermic or endothermic?
Negative, you're extra.
You're exothermic. So basically, if it releases heat as it stabilizes, then that means it's stable now.
So exo is you releasing heat.
So if you get an answer where it's like negative 250 joules,
That's endo. Or exo.
This is exothermic, yes.
And if it's positive, it'd be endo?
It's endothermic, so remember, in third, I'll send a second.
Explain electron affinity again.
Okay, so Jamie's question, and then
Is that
we'll,
50 and
then
60?
we'll switch over to yours. That is 50 and 60. Alright, so, you were asking about condiments, so remember, when thermodynamics, what is the part of the universe we're actually studying?
System?
And was there anything else?
Sun.
Okay, so your equations are based on the idea of looking at the system. If the system's gained energy, it's positive, so it's endothermic. If it's lost energy, it's negative. Okay, come through. Here's your answer parts for that. I'll take your question in a second.
How many points do you have?
0.
Sorry, Jamie. Sorry, Jamie. Alright, so electron infinity, Ethan, is what?
The energy to add
To add it. So if you add electrons to it and it gives off energy and is stabilized.
Why is it most negative at the top right there?
Alright, cause remember,
Aren't they the ones that want the
yeah, cause the ones that are in the ones that are in the top right, I can't just write it. The ones that are in the top right, remember those are like groups 16, 17, 15. They want electrons, so they're stabilized whenever they get them. So that's
So why
why
are they both negative?
Because remember, negative is exothermic, so they've released energy and now they're stabilized because of it. There you go.
So they're the most negative and top right?
Yeah, most negative in top right, least negative, or I think your exam says least negative because that's how your textbook words it, but instead of more positive, the more unstable it is because you're forcing
So
electrons.
least negative is top right.
Least negative, no, most negative.
Did you
Most
write-
negative is top
Oh,
right.
least negative is bottom.
Did you write this
Yeah.
exam?
Alright, Ethan, go through because you answered like parts of questions for that.
So wait, are the Aleutian Islands part of the United States?
This doesn't sound like it's related to
I know, but
right?
if I don't focus on something else, I get.
Alright, what is the corner that has the least ionization energy?
Ionization is the ability to lose one.
Is
So it's bottom up.
bottom left, because they don't want it. Sorry. Alright,
Is that 80 or 60?
that's 80. Alright, between a substance like, I'm gonna draw it up here so that way Quentin can still see it. So between Mg and Mg2 plus, which one is larger?
As I said?
Yeah.
MG2 plus,
Alright, so what's 2 plus mean?
more electrons.
If it's positive?
Oh yeah, more protons.
If it's the same substance, it can gain more protons?
Yeah.
Okay. So what's it mean? It's okay, this is good, but we're talking through.
So would it be the MG that's bigger?
It is bigger, but why is this one smaller? What's the 2 plus mean now?
I'm still not sure.
Alright, so can I gain, or so, can I gain and lose protons?
No.
Can I gain and lose electrons?
Yes.
So if it's 2 plus, does that mean it's gained electrons or lost electrons?
Lost
It's
electrons?
lost, so that's the reason why this one's larger.
Did I get to throw or?
Yes, you got it. So, remember, for cations and regular substances, the cations are always smaller. Alright, Ethan, if it's between oxygen and oxygen 2 negative, which one's larger?
Oxygen is negative.
Oxygen 2 negative, because remember, the
added.
anions are always larger.
Add in electrons.
Yep. Make sure Quentin can still see this. Good. No, you're back.
What if they're real darts?
Oh my goodness, it's not too hard.
I've seen people do that.
That sounds terrifying.
That's
What?
60.
It's like playing Russian roulette. but
That's
how it
60.
goes.
Alright, so give an example of an exothermic process. What's something that gives off, like, that would be an example of an
Cooking
exothermic?
steak?
What?
Cooking steak?
Is
no,
it?
No, that's in cooking tea. Does it have to be something that looks nice?
As long as it sounds like it gives off heat, I'll take it.
The sun?
That's a type of fusion, actually.
So it doesn't give off heat?
I mean, it gives off,
What about a heater? You know, a heater.
okay, I'll take that. It's kind of
Or
weird,
like
but
a
alright.
human?
We're warm-blooded.
Oh, okay.
We're cold-blooded.
No. Alright, what would be an example of a endothermic process?
Ice and water, melting.
Yeah, because the ice is absorbing heat to melt, yes.
Wait, what time do we show this again?
You get your break at 35. Alright, I wanna go back over these just to make sure we're covered all of them. Alright, what is the name for this shape? I'm holding up to the questions here.
Trigonal pyramid. Nope.
Tetrahedral, cause there's 4. Sorry, tetrahedral.
You broke it. You know, last year in biology I said I was gonna bring fossils, and I never did.
It's okay, coronavirus stuff.
Yeah.
Alright, what is the name for this shape?
Trigonal pyramid.
Yep.
Are they retarded by the time?
As long as you know the ruling.
Yep.
Okay. I'm sorry. What is the name for this shape?
Real
Is
depression.
that the trigonal plane diagram?
Yep.
We don't want to touch his mouth.
Alright, what is the name for this shape?
Linear.
Here.
Wait. What's his name? I don't know the picture. I don't know the pictures. I don't know the.
He was the president of the Confederacy.
Oh, Houston.
Davis.
Alright,
Jefferson.
what is the name for this shape?
Football.
50. Is
Alright.
that? Yeah, 50.
Oh, anyone have any questions about electron configuration? Like 1s1, 2s2?
I think I got it. It's a shortcut period, right?
It is a shortcut.
I think I did.
Alright, Chris, you have a question about it?
No.
Alright, what is covalent bond?
A covalent bond is between nonmetals.
Nonmetals, and then what's it characterized and what's the electrons?
They want more electrons.
Okay, so is it sharing, delocalized, or transfer of electrons? How do you put it?
Transfer of electrons.
For covalent? Just making sure.
Yes. Is it
So
sharing?
it's sharing, because remember they're both nonmetals, so they both want them.
There's like sticky tack on the wall.
Must be from a couple of years ago. I don't think I've put sticky tack on it recently. Alright, what is metallic bonding?
Metal between metal.
Metal between a metal, and then is it delocalized electrons or transfer of electrons?
Delocalized.
Delocalized for metallic.
We only get a 5-minute break, don't we?
Yep.
Oh, I need.
I need longer than that.
Alright, give an example of a nonpolar bond, Chris. Describe it.
London forces.
Love a nonpolar bond? Give an example. You have to draw it up.
Ionic.
For a
Oh, no.
nonpolar bond.
Alright, let's go.
Okay.
P. I don't know what that is. Plutonium, right?
Phosphorus.
Alright, and go CO. And go CL. Or do a single bond. No. Single bond.
G.
CO. How many does P start with?
P starts off with 5. I'm not sure what you're doing.
I'm
For
trying to
a
make it where it's
non-
where it's not even all the way around.
Nonpolar bond between two atoms. Not a non-polar bond.
That's polar.
Yeah, this is polar. I don't even have to get far for it. So, if I were to draw two atoms and to make it non-polar, what two atoms does it have to be? Or what would be an example of it?
Hydrogen. And then hydrogen and what?
That would be non-polar?
Hydrogen and hydrogen.
Hydrogen and hydrogen have to be equal sharing, so they have to be bonded to themselves.
So would that be a hydrogen bond?
Alright, this one would be, okay, go ahead, throw. I'll answer your question right now. My chalk is like thinking on me. Alright,
I did not
so this one is non-polar because it's equal sharing because they're bonded to itself. If it was something like this, hydrogen and chlorine, it's unequal. So this would be an example of a polar bond.
So
And
that
then
would be
you're right
dipole.
for intermolecular forces.
That would be dipole, London and hydrogen?
Yes,
South
because it's
second.
hydrogen bonded to, hold on a second. Actually, no, because what is, to have a hydrogen bond, what does it have to be bonded to?
Compare it with the hydrogen, right?
It has to be hydrogen bonded to what? Not chlorine, actually. I know it seems like it would be, but it's not.
Fluorine?
What?
Fluorine?
Chlorine, oxygen, or nitrogen. Those are the three it has to be bonded to have a hydrogen bond.
Once we complete
Oh.
our exam, don't we get a cane kit? knew it, man.
Alright, Chris, come through, I mean, not Chris, Ethan, come through, cause you're gonna do a lot
I'm
of
not
questions
gonna
to that.
touch you because you have cooties.
Oh, yeah.
Say coronavirus.
I have
Not
a
coronavirus, he has cooties. There's a difference. Like,
Ooh.
is that 100?
I believe so, let's
That's-
see.
That was the smartest move I think I've ever seen him make.
That's 100, yep.
That was a smart move. Wait, how many points do you have now? Do you have a buff? Like,
460 now.
huh?
460 now.
No, we're gonna see if we have some in a minute. Alright. What does hydrogen have to be bonded to have a hydrogen bond?
Oxygen. Wait, what does hydrogen have? Nitrogen for
Alright, so all three. You're right, fluorine.
nitrogen.
Good.
Oxygen.
Good job. Just making sure to have a hydrogen bond because it's not
Is that a
chlorine.
question?
Yeah, throw. Too hard. Alright.
I'm winning.
Give
so it's
an
fine.
example of the close packing ones, the ones that are able to have as most volume as possible in a small space.
The hexagonal close packing.
Good job. You want the other one? Go
Is
away.
it base
Go away.
center?
Base centered cubic.
I'm gonna get a peek at the exam.
No, get out.
Ethan, I have
Alright.
exactly 20 points more than you. That'd be 20. 20.
Yeah, 480.
Yeah.
I have 170.
You have how much?
170.
Alright, about 4 minutes. Alright, Chris.
Ethan.
Oh, it is Ethan. Alright, Ethan. What do you call the atomist electrons?
Valence.
Alright, and how many does atoms typically want to get? 8. Bro. Alright, what do you call the measure of
That's
disorder?
100.
Measure of
Oh,
what?
it is. Measure of disorder or randomness in a system. E.
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 Measure of.
Randomness or disorder.
Is it a weird word?
We learned it.
Oh,
in
yeah, I
the
know
dynamics
this one.
Chapter.
Yeah. It's such a weird.
Yep. Weird.
Oh, is it, it's like your wall. Not your. I can't say it. I can spell it.
Okay.
It's like E-O-U-T-R.
Alright, Jamie, let's go to you.
Is it entropy?
Entropy,
That's
and
what
then
it-
what thought, and then what law says that entropy is increasing and usable energy is decreasing?
Second law?
Yep, I'm sure.
That's all I have to win. If Ethan botches his next ride, win.
So I know that.
Because all I need to beat you is you got what? Botches to say that.
590.
So I need 110. I think we can do that. 60, 50. But if you get something, I'll probably go. If you get another 100.
Alright. Ethan, what is the energy of motion?
Kinetic energy.
Okay, what's the energy associated with the position of an object? Potential energy.
Want to get another question?
One
more?
You have like 1 minute to determine how fast I'll go. I have to go through the paper.
What is that?
50.
Alright. What is the device that's used for measuring heat flow?
Quadrometer, quadrometer, calorimeter.
There you go. Throw.
I could get 100 sometime here.
Hurry, hurry, because everyone else gets a chance too, since you started.
Got lucky. Yeah.
Alright, I bet.
Alright, Jamie's turn. Alright, Jamie. What is Avogadro's number?
Oh, is that the 6.00 times 10 to the 23rd?
Not 6.00.
6.34?
Nope.
6.066?
Nope. 6.66.
I
No,
know.
0.
666.
Alright, Ethan.
6.022 times 10 to the 23rd.
Yeah, 6.022 times 10 to the 23rd.
This is new. It's a weird feeling losing.